Hello and welcome to the FluCoMa podcast. Today I'm talking with Dr. Milad Mardakheh, who is a composer, sound artist, programmer, and researcher. With a background in computer engineering, Milad mixes computational techniques with a whole host of musical practices and spanning a variety of genres from rock, metal, and film, and theatre to acousmatic, electronic, and computer music. His work has been featured at festivals across the world, including NIME, ICMC, Klinkgut, and Beast. Today, we'll be learning about his creative process and his various uses of the FluCoMa toolkit. So, Milad, hello, and thank you for joining me today.
Hello, Jacob. It's great to be here. Thanks for having me.
You're quite welcome. So perhaps you could begin by telling us how you got into music and perhaps also some of your background in computer engineering.
I got into music from a very early age. As long as I can remember, there was always an instrument at home, and my dad and my uncles played Persian music instruments, so they played sitar and tar. And I grew up in a family that sort of cherished music, and my brother played the guitar, so I was always around music as a kid. I need to separate those because my computing background is also kind of feeds into it. It started from an early age as well. Music and computers were always there. Growing up. From the age of 8 or 9, I started playing the violin. And then as a teenager, I was playing in youth orchestras. I sort of taught myself the piano. And when I was in high school, I got super into metal. And met a few of my classmates who shared that same taste and the subgenres of metal that we shared around that time. So this was like mid 2000s, so it was at the peak of alternative, new metal, or just past the peak of it, So we were really into that stuff, and I think I was 16 or 17. I started writing music, so we formed a band, and we were covering bands at first, and I was the main vocalist, and I started also playing guitar for the band. It was easy enough. And I started writing music for the band, and that sort of got me into composition. And most of us in the band were classically trained anyway, so we could read and write music. And and that's sort of where my journey as a composer began. And became more and more serious. I'm here now, kind of continuing that journey onwards, which, to be honest with you, I did not expect to end up here doing what I'm doing now at all. When I was 15 or 16, I had completely different goals. I wanted to write film music, and I did for a time. We had sort of our bassist in our band was kind of my all-time music partner as well. I've written most amount of music with him than any other person in my life as a duo. So we sort of work very well together. Our sort of creative waves are kind of synced or can sync up. So he's also a film director. And so he had links with lots of other sort of theater and film directors studying at his university, at the Art University of Tehran. We got commissions from sort of small student projects to sort of bigger ones, and we kind of both got into writing film music. So it kind of expanded from there. So to backtrack, my computer engineer background stems from the fact that I, grew up with an engineer dad and an electrical engineer. And so he got me into electronics from a very early age. He would buy me sort of self-assembly kits, making an FM radio on a breadboard and whatnot with following schematics. And we always had computers lying around as well because of my dad's job. So, I remember before I was born, there was already, and when I was born and afterwards, there was already a Commodore 64. And, it was 1991, so it wasn't that long ago. But, it's Iran, so, tech was a bit behind. So yeah, I remember as a kid, I used to just play video games on them, but Commodore 64 ran on BASIC as the OS, and I remember my brother taught me sort of the simplest of codes, which was the beep function, and you could. I think that's probably the first line of code I've ever written in my life. I must have been 3 or 4, probably 4, for something. Yeah, he taught me the beep command, and I would just put it in, and I would put different pitches in. And at that time, I did not know what those letters meant. I just knew that they went from A to B, all the way ABC, yeah. So I would put random pitches in, and yeah. So fast forward, I studied computer hardware engineering for my bachelor's degree. But I stayed a musician. And I had our band as well, and we were recording albums, and we recorded 2 sort of 1 EP and 1 full LP, 1 larger album. So we were also doing shows underground in Iran. Of course, it was illegal, and it kind of still is. Very oppressed environment for musicians and just generally artists all around. Still to this day, unfortunately. So yeah, it was risky, and it was very exciting to be in that underground scene as well. So while I was doing all that while I was continuing my sort of first degree in my bachelor's. At that time, I was a bit conflicted with the sort of dichotomy between them. Admittedly, I was not aware of computer music or electroacoustic music at that point. I was just fully immersed sort of in the metal scene and in the popular music scene. And stemming from that, film and theater music. But I always knew I wanted to study music properly. So I had no academic background in music. So I was trained and I received classical training, but I didn't really go to a conservatoire or university to study music until my master's, basically, when I came to the UK. At that point, I already had a portfolio of works that I'd done for film and theater and my albums with my band. So I got accepted at the Royal Welsh College to do a composition course, and then I came here to the UK. And it was at that point that I was introduced to electroacoustic music and computer music, and the wonderful tutors that I had at Royal Welsh College. They really encouraged me to kind of utilize my computing skills, and I discovered Max. And I already had a background in coding, and I understood the basics of programming, so I picked it up really quickly. And of course, documentation and help files and Max are amazing to really get someone going really quickly. So yeah, that's kind of my background and where I come from and how I got to where I am. And after I finished my master's, I of course did a PhD at Beast, at the University of Birmingham, and I focused on data sonification and science art. In particular, I took data, protein and RNA data from cancer cells. It was a collaboration with Bart's Cancer Institute in London. And they provided me with this data, and I designed various patches, and I sonified this data, and I wrote music that reflected cancer as a disease from a biomolecular standpoint. So it was a collection, it was a portfolio of science art pieces. Actually, it was a mixed portfolio because there was also a bunch of patchwork that dealt with the technical side of data sonification. Yeah, so that's the gist of it, I would say.
Yeah, great. Well, so as you were just saying, so yeah, data sonification is something that's figured quite a lot in your work. And so you've written about it, was the subject of your PhD. So we'll be going into some of the specific details of the techniques that you used in a moment. But I wonder if perhaps first you could talk about this concept of data sonification in general, what it means for your work, and perhaps also talk about your metaphor of the strata, which comes from your PhD as well. So what does data sonification offer you as an artist, and how do you approach data from an aesthetic point of view?
So personally, I mean, at the beginning, data sonification itself sort of provided me immediate sort of access to novel material that I would not have attained, personally or manually, I should say. Well, not manually, but I get what I mean. As I dived into it, then specifically when you mentioned the strata metaphor, so I discovered some things about it, and doing literature review and certain sort of controversies and friction with practitioners that use data sonification became apparent to me. What it provides to me personally, to kind of give an answer to that before I move on to the strata metaphor, is another dimension, is another sort of set of controllers and set of almost like another performer, really, the data itself that feeds into what I do, that interjects me and that guides me sometimes, in live performances that I do and improvised performances that I do. So not only it provides me with material, the novel material that I can make use of in compositions, in fixed compositions, but I have a sort of closer relationship with it in terms of performance. The strata metaphor is actually kind of a later fruit of the project, and it came about as a result of sort of common questions that I was just asked quite a lot during my PhD about why I was doing what I was doing. Because essentially what I was doing is I was writing music about the science of cancer, and I was using this conceptual framework called the hallmarks of cancer, which is a sort of widely accepted conceptual framework that is proposed by Douglas Hanahan and Robert Weinberg, and pretty much everyone in the cancer research field kind of recognizes this. So it's kind of canon. And it kind of, as I said, it provides us a conceptual framework for various biomolecular processes and within the cell itself, from a biomolecular standpoint, what happens in the cell, what sort of proteins change and how do they change, how do they sort of certain inhibitors or inducers kind of work together that causes a certain condition or a hallmark in a cell that is becoming cancerous. So I was taking this data and I was using the narrative of these frameworks, these hallmarks, as musical narratives. So I was translating them. I was employing lots of artistic tools. I was juxtaposing material. I was drawing analogies between sound material and what was described. The sound material itself was generated from the data that I was getting from Bart's Cancer Institute, from the research that they were conducting. But essentially the story that I was trying to tell, so I would sonify this data, and then I would, in the beginning I had a purist mentality. I just went with whatever I got, so whatever the design of the sonification system produced. And of course there was my influence in that to a significant extent as well. I would just take that and present that. But then as I went on, I realized that was not really enough. I wasn't able to generate really interesting musical results. So I was doing things more in post, which were still informed by the context behind the data. And whenever I presented my work in conferences and talks and seminars, I often this question often came up. That so the question was that, we know that what you're doing, yes, you're taking this data, you're turning it into sound, and then you take that sound and then they're manipulating it, and also your design choices in the patches that are sonifying your data are affecting your results. So why work in this way at all if the listener So they would ask, can the listener really like identify anything about this data in particular in the sounds? And the answer was no. They cannot really. That's not really the purpose of what I'm doing. I'm creating pieces of music. Then they would say, well, then why are you sonifying this data? What's the point? Why not just use just oscillators and random algorithms instead? So this question kept popping up and really bothered me, because I kind of felt that there was value in what I was doing, and I was doing it this way because, well, it meant something. It was the same data and it was related to the context of the pieces that I was writing. So it made sense. It had conceptual significance. So yeah, I set about to answer this question, and the strata metaphor was a result of the research that I was doing, and this was towards the end of my PhD, during the writing up process, really, or the last year of writing up. I kind of put this paper together with Scott Wilson, my supervisor. So yeah, I did a literature review, and there's always this contention. So this question also feeds into or reflects this contention that or friction in the field, where people, the boundary between scientific data sonification and artistic data sonification is really blurry, and often things get mixed up, and someone with scientific expectations is expecting some very rigorously designed data sonification system that produces comprehensible results, comes and listens to a piece of music that employs data sonification and says, well, I can't understand anything. This is rubbish. This is arbitrary. It might as well be random sounds. I did a literature review, and I found that there are certain practitioners who already propose certain solutions, different terminology, like Scott Gresham Lancaster, for instance, proposed, different orders of sonification, like first order sonification, second order sonification, to kind of tackle that. Carla Scaletti proposed, not using the term data sonification at all, if you're writing a piece of music, instead using the term data-driven processes or data-driven music to kind of really avoid the contention, not really address it. I was talking with Scott, and I was like, well, this person, I've done this literature review, and this person says it like this, and that person says it like that, and so, but that doesn't really quite cut it. That does not really provide a solution to the problem. We're still kind of lost. If we want to talk about this dichotomy between scientific and artistic data sonification, or whether there should be a dichotomy between them, maybe that's what's lacking, a framework that kind of explains what is going on, or gives you kind of a roadmap to see where you stand as a data sonifier. So that's how it came about. We kind of identified three categories, three categories of artistic data sonification that are not orthogonal, and we don't consider them orthogonal or separate. We consider them cumulative, and much like a strata. And one builds on another. And the three categories are generative, elusive, and curatorial sonification. And based on the importance of conveying salient aspects of data to the user who's designing, to the designer, the user, and the target audience, approaches can occupy different categories simultaneously. So works can be received on different levels, based on who the target audience is and what the purpose is. So generative, to just give you a brief explanation, generative is usually the kind of approach to data sonification which mainly benefits the artistic results. So there is little or no concern for the meaning of the data or conveying any specific information about the data itself. What matters in generative data sonification is just getting the sonic results, which can, in that case, be generated by anything. So, the data that is used in that process might as well be fake or arbitrary or random generated. It doesn't matter really what sort of data is being used. What matters is how intriguing the results are. And so we can also kind of draw a link even between serialism or post-serialism practices with data sonification so that would kind of translate into data sonification in a way. It's not really a robust description, I would say, but using instrumental and vocal resources, you can say, or chance-based operations like Cajun or music in that sense. And what I was doing, of course, in my project was not generative strictly. I did have pieces that employed certain characteristics of generative sonification, but what I was doing was sort of a layer further down or further up, depending on how you look at the strata, which we ended up calling elusive sonification. And that is where we can start realizing a bridge between the science and the art. So with generative sonification, as I said, there's really no benefit to the science. What matters is just the use of the data by the artist. But with elusive sonification, the sonifier alludes to the data set, the meaning inherent within the data, or the context behind it, or the relations between the data values. What really sets it apart is that conceptual weight that comes with the sonification. And it's important that if you're employing elusive sonification, that the listener knows the source of the data set and where it's coming from. In generative sonification, that's not important at all. It doesn't matter. What matters is, as I said, is only the sonic output. But with elusive sonification, that does matter. So contextual information provided with the sonification experience, or a way of acquiring it, is crucial in achieving this level of sonification. The end result, of course, is still the listener will not be able to figure out or understand how exactly the data is being heard in the sound, or the relations within the data are not necessarily immediately translated into the sound for the listener. What matters is that scaffold, which we ended up calling it, this sort of conceptual scaffold that the user can hang their experience of the sonification on. And in a sense, it provides a tangible experience of abstract numerical data. And because the listener knows where this data is coming from or what this data is, it kind of functions partly educational and partly as an outreach activity for the science. So it does feed back into the science. And what I was doing in my PhD and my methodology and my approach mainly fell into this second layer of alluding to the science behind the data. But of course, if you went further, the third layer, if you really wanted to convey specific salient aspects of the data to the listener or to the user, disregard anything else, any other part of the data that is unnecessary or can be considered as noise. So you're really focusing or curating information to the user, then that's a different approach. And we ended up calling that curatorial sonification. So with that, you go further into the realm of pedagogical. Your intention is not to create a piece of music, as opposed with elusive sonification, which is mainly used for creating pieces of art, installations of music. What matters is creating a sublime sensory auditory experience in elusive sonification that allows the public or the listener to engage with the science behind the data. But with curatorial sonification, of course, the intention is to accurately convey comprehensible information. The result of curatorial sonification, of course, is auditory displays, and we can see it in the works of the late Mark Ballora, numerous sonification projects that he did. Lily Asquith's sonification of particle collision data and many more projects that are out there, and they're more sort of practical, or in that case, scientific approach towards turning data into sound. Yeah, sorry, went on another tangent there, but that's the kind of brief abstract of the maybe not so brief of the strata metaphor. What it provides to me is that it allows me to identify first of all, identify who I'm producing sonifications for, what's the purpose, who the target audience is, and then what I should keep in mind in terms of design, in terms of output, results. What should I focus on if I'm designing a sonification system that is supposed to convey information? Then I know I should not be convoluting that information, and instead I should actually be clearing out the noise and make sure that I'm highlighting the information to be conveyed. We were hoping that this would at least. It was published in Leonardo in October, so it's fresh. But we were hoping that it would at least address this long-standing contention that people have written about. That is this artistic? Is this scientific? Why are you doing this? What's the point? So some of these questions and this friction that has been there. We're hoping that this would at least provide a stepping stone in addressing some of that.
Yeah, no, some really beautiful ways of thinking about this kind of stuff. Sounds really fascinating, and it kind of made me think of some of James Bradbury's work, who worked on the FluCoMa project, and yeah, he didn't really do data sonification as such. He kind of took processes. For example, he did a lot of I think it's called data moshing. Where he kind of he scraped his entire hard drive and appended a wave header to each file and sort of transformed it into sound, which could or could not be considered as data sonification, I suppose. But yeah, what's interesting is that over the course of his PhD, he kind of had different trajectories of taking that sound, highly curating it and arranging it into the beautiful music he makes, and then he has some projects where he just keeps the original data as was and kind of makes no transformations at all. And yeah, so I suppose what you're talking about really kind of gives an interesting framework of thinking about those processes for the artist to think about how you engage with the sonic material that you're creating. But so yeah, it seems that in your work, the semantic kind of signification is very important. And
it is. Well, in my PhD work, yes, it was. Yeah. It was kind of central to deriving narrative out of the text. Yeah, in terms of, what you were describing, the practice of sonification, file types, that reminded me of Al Bonotto's work as well. So he has this work, Data to AIFF, where he has sonified various, files with different, headers and file structure, of course. The handbook kind of refers to this as some form of modification, although the term modification itself is not really consistently applied in the handbook either. But that it was curious that you said that, because that's one of the specifically one of the examples that we kind of covered in the article as well, talking about generative data sonification, where that practice of sonifying different files, essentially, which you can also achieve in Audacity. You can just import any file into Audacity, and you would get immediately a notification of it. Which is, yeah, it's fascinating. I mean, it's like the strata metaphor is not really to say whether there's value in one or there isn't. It's more sort of differentiating where you stand or knowing what you're doing and what that would sort of entail.
Yeah, of course, yeah. Yeah, and I do know that James is a fan of Alpha Nocto, as am I.
As am I as well.
So perhaps quickly before getting into some more kind of concrete examples of some of these things that we've been talking about, perhaps just to round off the kind of introduction to your practice. There are two major aspects of your work, which are, on one hand, live improvised performance, and on the other, more kind of fixed acousmatic pieces. I wonder if you want to perhaps talk about these two practices and the differences between the two approaches, and if there are common themes or approaches that may span between these different activities.
Yeah, absolutely. Well, the live improvised aspect of my work is something fairly recent, and it's something that I would blame FluCoMa for as well. It's a kind of instigator for me really diving deep down in that rabbit hole. But yeah, it's something that I started in, I would say, the second, third year of my PhD. So up until that point, I was mainly writing fixed acousmatic pieces, yeah, it was. I mean, in terms of how I generated material, it was always through improvisation anyway. So because I built these sonifier patches, and I would just sit in the studio playing around with them for hours and hours, and I would record that material. And that's still the way I work in terms of generating material. To this day, I still do the same thing. But at that point, I really didn't think about performing these improvisations, live to audiences. It really came about when I started experimenting with cat-RT, or cat-RT and concatenative synthesis, and so that's kind of one of the common themes between my acousmatic work nowadays and live improvisation work is the use of grains, is the use of granular synthesis and concatenative synthesis. That's something that really connects them, or perhaps was one of the culprits of swinging me or pushing me towards live improvisation itself, as performance. So my experiment with cat-RT kind of, I started recording some of the improvisations that I was doing, and I started also implementing structure and sort of directives or conceptual directives, stemming again from Hallmarks of Cancer, which I was focused on around that time, and experimenting, with the extent of my control and the extent of data-driven elements that were in play during performance, and this sort of strand of exploration was kind of what encouraged me even further to keep going and to actually play live. So recording my performances and then realizing that actually that doesn't sound bad. I could actually do this at a concert, and there's enough intrigue in it, hopefully, that it's not going to bore people out of their minds. So in terms of material generation, I think improvisation itself and spontaneous response or musical expression is still very strong when I'm working. And it's just different modes of presentation, really. Of course, with fixed compositions, you've got a lot more time to get feedback, sort of extended feedback through time, and the more time you spend working on a piece, of course, like the more you realize different things about it, and different things that you could change or improve or develop further, and those experiments kind of lead the piece somewhere else. So yeah, but of course with live improvisation, it's all in the moment, and that aspect of it is something that I found, or I came to find really intoxicating. Being fully in the moment and not really knowing what's going to happen, and just starting something with pure free improvisation with certain material, and then ending up somewhere completely unexpected. That's something that I personally really enjoy nowadays, and it's pretty much become or consumed my practice. I mean, I still I write fixed pieces, and in fact I have an album coming out soon, which is a collection of fixed pieces, mainly written in Super Collider. There's some FluCoMa generated sounds, and using my patches in Max as well, but mostly it's in Super Collider. So the live coding as well also is kind of intoxicating. And I remember Scott Wilson once told me that programming can be really intoxicating, man. Like, you got to be careful. And I totally agree with him, because it just pulls you in, and and then you realize that you spend months just working on a patch, just changing things, and have not produced any musical results. So maybe live improvisation, in a sense, also remedies that for me, because I can just take that patch to a concert and force myself to make music with it, rather than sitting at my desk here and changing things, very minute improvements. I would say.
No, well, I certainly understand that dilemma of spending months on a patch without actually making any music with it. Yeah, certainly. But I'm glad to hear that FluCoMa instigated that part of your practice. Then, in part, that's it's good to hear.
Yeah,
brilliant. Yeah. So yeah, I'd love to get into some more kind of concrete examples about some of the stuff that we've been talking about, and sort of in passing, maybe hear about some of the ways in which you've been using some of the tools. So one piece that uses some of the data sonification techniques that we've been talking about is Malignant Grains from 2020, so which uses decomposition and reconcatenation. It also stands at an interesting crossroads between improvisation and electroacoustic music, which you've just kind of been talking about. So yeah, I wonder if you could talk about the piece and perhaps explain how it works.
Yeah, of course. So yeah, Malignant Grains, I would say, is a significant piece, because that was the piece that started my sort of live improvisation practice. That was the beginning of it all. That's where I started recording my performances, and I realized, okay, I can do this actually as a set, as a performance set. The way that it works, it primarily incorporates or uses CatRT, but a modified version of CatRT that actually for Malignant Grains, it was partially data driven, but it was mostly controlled by me. And in many senses, it was an exploration of the capabilities of and versatility of CatRT. But nonetheless, it was using sonified material. So the sound material that was being decomposed and reconcatenated was all generated by my other patches, which sort of incorporated other approaches to data sonification, parameter mapping, model-based sonification. And also some recorded material was there as well, some recorded material from the environment, so and the ambience of the laboratories of Bart's Cancer Institute. I did a couple of recording sessions there where I recorded mass spectrometers and different lab equipments that the mass spectrometer was actually responsible for generating the data that I was using. So I thought that was an interesting kind of angle to have, or sound material to have. So it was a combination of these sounds that was going into CatRT, and then, of course, I was manipulating different parameters, manipulating textural elements of the output of CAT-RT, as well as gestural articulation. Some of those textural elements were also mapped to the sort of data traverse patch that I had, which traversed my high throughput massive data set in a time-based manner. And that was sort of one of the key patches that I made initially in my research, which was not really musical itself at all. It was just, traversing through the data in a time-based manner, and the time-based aspect of it was because I intended to use it in a musical sense. So I wanted it to kind of be, paced at a certain, rate. So yeah, I started experimenting with this modified CAT-RT, and that was sort of what gave birth to Malignant Grains. So I started doing some improvised sets, and I eventually picked one that I was happy with as a recorded presentation of that improvisation. But of course, I played that piece or improvised that piece in concerts, and every time it was different. But not entirely different. So as I said, I had directives. I had aesthetic directives like structure and pace of development of material that were derived from cancer research. So, for instance, every improvisation that I did, I started with really crackling short grains and very sparse grains, and from that I built into really complex and rich textural drones. And this idea of building from a tiny sort of small element to a larger sort of malignant, massive mass of sound was directly, kind of derived from the idea of malignant growth, the idea of, a singular cell organisms becoming malignant and forming sort of, macroscopic tumors. So that was one sort of, for instance, aspect that was directed in the improvisation. And of course, it is also significant because it sits in, as I said, it was at the moment of inception of my live improvisation practice, and I went on to develop the modified CAT-RT patch further, which resulted in another piece, which came after, and it was titled Malignant Angiogenesis. And that is in many, this Malignant Grains, this piece, this improvised set was in many ways an independent study for that piece. So that was a much bigger piece. It was an audio-visual piece as well. And then from that point onwards, of course, I was introduced to FluCoMa, and I realized that I can actually make my own CAT-RT instrument using FluCoMa, which I did, and that led on to other pieces, other live improvised pieces like Data Dialogues that also incorporates modular synths, and it's a multi-channel live improvisation piece. So yeah, in many ways, it is also significant in that way that it kind of led into more developments and expanding on what I was doing in my improvisation practice.
Mm. That's interesting to hear that. The data sonification is at different levels. It's not just the creation of the sonic material. It's also mapping to control data, but also in this kind of macroscopic trajectory of the piece as well. It's interesting to hear that it's really got this kind of overarching thing. I'm interested to know, given the sort of elusive approach to data sonification that you talk about, how you present that piece to an audience. How do you let them know what's happening? What kind of intel do you give them before you start playing? So mostly, I mean, in sort of academic concert music settings, maybe not necessarily academic, but concert music settings, of course, you have the medium of program notes, and a lot of that information, although briefly shared with the audience, was written in program notes.
telling them where this data is coming from, first of all. And of course, those who were intrigued or who were curious would always approach me after the concert, and they would ask more detailed questions, like how exactly did you do it? Like, what was directing your improvisation? And of course, I would share details like I did with you about like more specific elements that were guiding my performance. But I guess that's the tricky part, especially in concert music. Of course, not everyone really looks at program notes all the time, so it is a problem. Of course, I have also experimented with actually, using text as voice, using voice reading out text inside the piece itself. So you would hear some a voice sort of sharing a little bit of information or clarity that that this is the data set, or this is where it's coming from. Or with Malignant Angiogenesis, as I said, it was an audio-visual piece, so having that visual aspect was another sort of way to tackle this, to kind of at least highlight that there's some data in play here, and that's what is guiding it, and hinting at it, so alluding to it, in a sense, which is the essence of elusive sonification. But that's crucial. Yeah, the audience needs to know that where the data is coming from. Otherwise, it'll be experienced as generative sonification. Otherwise, it might as well be arbitrary if they don't know where it's come from.
Yeah. So you talked there about using some of the FluCoMa tools to make your own kata-arti instrument. I wonder if you maybe want to talk about that process. What, obviously, all the respect to kata-arti, what was perhaps missing in that interface that you wanted to include, why you felt that you wanted to build it up again, and maybe talk us through the sort of workings of that.
Yeah, of course. The main reason that I embarked on this little project was purely curiosity at the beginning. It wasn't that kata-arti was, for me, not working. It was, but I as a programmer, I had an itch that I wanted to scratch, which I know you can also relate to. And I saw James Bradbury's sort of design of a 2D Corpus Explorer using FluCoMa, and that really inspired me. And I thought, well, I want to do this myself, and I want to, and then I want to experiment with it. I want to try to augment it and grow it from there, which is what I've been doing for the past couple of years, I would say, or a year and a half. That I created the two-dimensional Corpus Explorer patch. So it's grown quite a bit now. Like it has 4 different voices, or 4 different sort of corpi that can play at the same time, and there's a host of sort of features like automating different parameters, and also recording live input and concatenating and splitting and concatenating it in real time, as well as machine listening, which manipulates different parameters of playback, as well as corpus navigating the two-dimensional Corpus Explorer. And also Simon Smith, the sound technician at the University of Birmingham, who was a colleague of mine at that point when I was doing my PhD at the university, he was also very interested in it, and together we kind of formed this like little Max Club at the university. There was unfortunately no Max Club at that point. I don't know if there is now either, but well, there's ours, but I'm not there anymore, unfortunately. So we formed this small Max Club, and we started sort of piggybacking ideas and sharing patches and troubleshooting and debugging each other's work, which also ended us playing together as well as a duo, and we occasionally do that. So we kind of have similar versions of the same patch, the same sort of core design, but each of our sort of patches have different capabilities, which is suited to our own specific uses or practices. Yeah, and then obviously the machine learning objects in the FluCoMa toolkit are magnificent, and I find myself experimenting with them all the time. Like even to solve some very simple task, I often find myself going to the multi-layer perceptron regression model, which sometimes it might someone might look at it and be like, that's really unnecessary. You don't really need to train a regressive network to normalize some incoming values. But it's sort of that experimental that itch that I tend to do it just for the sake of doing it. So yeah, that I've made a lot of use actually of the various objects in the FluCoMa toolkit in the past couple of years or year and a half that I've been developing these patches, and especially in terms of live audio input. Nowadays, I'm experimenting with live instrumental inputs. I'm using sort of chroma analysis objects and pitch analysis objects to exert control, some control on certain aspects or certain parameters of the patch, but not all of them. And there's this kind of interplay between me and the machine listening module, depending on what sort of audio input I'm working with, and what data I've trained which I've trained the model with. I'm using at that point.
Yeah. Yeah, and shout out there to Simon Smith, who was on the podcast perhaps a year ago, maybe a bit more. I can't quite remember, but yeah. Yeah. No, well, it's good to hear that the existence of Max clubs in the world. So you're talking there a bit about malignant angiogenesis, which I must admit I've not sure what that word means, so maybe you could clarify. But you were talking about the audiovisual aspect of it, so kind of informing about some of the semantic signification behind the piece. So I was just curious as to how that audiovisual aspect works. Is it mapped to the patch? Is it jitter processing, maybe, or how does that work?
It is actually fully implemented in Max MSP using JIT-GL objects, and that was another tangent or rabbit hole that I dived into. But that had a good cause or a good reason. The animation patch in that piece actually is a fully sort of autonomous director in a sense. And I designed it in that way because I wanted to fully focus on improvising, and I needed my hands free to operate the faders and the knobs. And I did leave myself some control to just hit a button and progress the scene. But it's essentially an audio reactive patch that, in addition to having 3D elements in the jitter world context, like moving or changing or being manipulated based on the input audio or the generated audio, it also transitions or directs from different scenes to one another or back to sort of the 3D environment. And the material that we used for that, so that piece is a result of a collaboration between myself and a visual artist friend of mine, Essam Hemmati-Farouz, who's Iranian, and he's a painter and an animator, and he's a very close friend of mine, and he was always very interested in my work. So we would have chats about what I'm doing, and I would describe my work, and he was quite inquisitive about it. He would ask questions like, what does that mean? Like, what are you exactly doing? So I would explain to him, a bit more in depth, the concept behind the piece, like what angiogenesis is, for example, to answer your question, is the process of the formation of blood vessels in the body. whether microscopic or macroscopic. That process is called angiogenesis, and it's a natural process. So normal cells and normal sort of tissue generation depends on angiogenesis. But what happens in cancer cells is that the switch for angiogenesis is always on, is chronically on. The normal cells or normal tissue basically can regulate that switch. So if there's a wound that needs healing and the new blood vessels need to be formed, so the switch will be on. Or menstrual cycling, for instance, the switch will be on, but then it will be able to be switched off. What cancer cells do is that they circumvent this natural barrier, and the result is that blood vessels are constantly being created or sprouting around a malignant tissue, which obviously then can supply that malignant tissue with oxygen and nutrients and remove metabolic waste, which will result in further growth. So, sorry, a little extended parentheses there.
No,
going back to my collaboration with Ehsan. So, yeah, I explained what I was doing and the process of malignant angiogenesis and some conceptual information. And a couple of days later, he sent a sketch, an animated sketch to me, just randomly. A very short, sort of hand-drawn, animated, two-dimensional 2D sketch, and he was just like, yeah, I was thinking about what you told me, and I just drew this, and that kind of started this collaboration. I was like, hang on, well, let's take this further. Let's do more things with this, and eventually we ended up working together on malignant angiogenesis. So. He animated or provided me with around 8 to 9 minutes of animation, which he had hand drawn himself, based on various concepts related to my research, to cancer research. So various sort of hallmarks of cancer. So it focuses on cell proliferation, tumor generation, and also angiogenesis at the same time. And he also did his own research, and he looked at the antiquity of cancer, and Hippocrates and Avicenna and how they described cancer around that time. So he sort of factored those in his in terms of his aesthetics. So that's kind of how that piece came about. And I knew that I wanted to do an live audiovisual piece, but I needed a way for the visuals to, as I said, autonomously be directed without me having to worry about what is on screen. So I designed this max patch that using JIT-GL objects that essentially did that based on input audio, yeah, that's how it came about. I'm not sure if I answered all your questions. If I didn't, please do.
Yeah, no, certainly. Well, it sounds like a really, really interesting relationship work on this piece with Ehsan. And so, does he have many sort of computational? Is he familiar with kind of generative art? And so, how did that? Was it literally he would send you over hand-drawn artwork and you would translate that into the kind of JIT-GL realm? Or how? Yeah, I'm really curious to hear about that process.
Yeah, of course. Yeah. So yeah, he is familiar with generative art, and he works in Touch Designer. Although he mostly focuses on sort of manually animated results. So like he draws his own sort of each frame and then animates it. But he is familiar. And of course, we looked at a lot of reference material when we decided to actually embark on this project. We did look at a lot of generative art, a lot of audiovisual art. One sort of very direct source of inspiration was Ryoji Ikeda for that specific piece, his project Datamatics in particular. And of course, Ryoji Ikeda's work was an inspiration to my other work, works in this portfolio as well. But in particular, the datamatics projects, the audiovisual works that he has done, were kind of our reference material for this. And the way that essentially the visual aspect of the work works is that there's sort of two worlds. One is the sort of 3D text-based animations that are designed by me, that are reacting to the input audio, and they're fairly simple transformations, moving about, changing sort of brightness and intensity and color, and presence within the entire 3D field. So there are moments that the text sort of fill the entirety of the window, basically, of the screen, and then there are moments where we kind of cut into these hand-drawn animations which were driving the narrative of the work. So the 3D text-based animations were not really functioning as a narrative device. What was kind of conveying, or we were trying to convey information through, was those cutscenes that Ehsan had more sort of intentionally, or I would say intentional. I mean, sort of in a more directed way, drawn or designed to say something. And there was, the use of symbolism, of course, a minimalistic portrayal of cell proliferation, for instance, using really simplistic shapes and circles, for instance, for cells, and lines for blood vessels, and the interactions between these sort of minimal elements was attempting to convey the process of angiogenesis and tumorigenesis in general. So yeah, essentially what the animation patch that I designed does is that it allows to cut between these worlds, but is tailored to live performance and live improvised performance, which means that every performance obviously is going to look different as well as sound different, and it allows for flexible durations and it gives myself as a performer flexibility to generate the visual material as well as the sonic material for each performance, and yeah, it was kind of a pain designing it that way to get there in the end, but we did, to refine it in a way that yielded convincing results, but we got there in the end. I would say there's a fair amount of control, sort of artistic control in that piece with the visual element. I mean, it's a combination of indeterminate and determinate sort of elements guiding the visuals, which kind of is an interesting interplay because I was improvising as well in the audio aspect and the musical side of things. So yeah, and as I said, this piece kind of led to another piece of work, which is Data Dialogues, and it was a sort of constant development that led from one step to another.
Yeah, well, we can talk about Data Dialogues. So it was a piece from 2022. So as you said earlier, that also integrates modular synth into the mix. So I think that also gives a good opportunity to sort of talk about instrument design in general and how you conceive of your systems as a whole, and sort of how you see those various moving parts sort of fitting together. Yeah, I'd love to hear about Data Dialogues.
Yeah, of course. So Data Dialogues was what came to existence basically after I had designed my own Corpus Explorer using FluCoMa. And I started experimenting with the Make Noise microsound and tape machine that we had at Beast, And around that time, it was sitting in the studio, and I just started playing around with it, and I kept going at it. And I think for the most better part of a year, I was just generating material using that. It was amazing. It was fascinating, really fascinating machine. How it came to become data dialogues in the end was me trying to kind of draw a link between my data sonification or data-driven processes that I was implementing in my max patches and the modular synth. From an instrument design perspective as well, it's kind of my tendency to link different tools that I'm using, to make sure that there's interconnectivity. And that's one way that I kind of conceive when I'm, the whole process of instrument building or using those instruments in my live performance sets as well. So with the different modules or patches that I'm using in my work, I feel like there's a tendency, or there's this like compulsion for me to try to feed the output into the input of another, from one into another. So linking them together has always kind of been an angle of exploration and experimentation for me. And I did the same thing with the modular synth, with the Make Noise microsound and tape machine. So I had my sonifying patches. I had my two-dimensional corpus explorer that I built in FluCoMa together with Simon, and I had the Make Noise, and I thought that, well, I kind of want them to be related to one another. So I'm going to try to modulate the modular synthesizer with the data. And that's how data dialogues came to be. I mean, right up until its performance in 2022, the concept was not really clear. I mean, I kind of knew what I was doing, but the fact that I was having a dialogue with the data became more apparent to me towards the actual premiere of the work. And the way that it works, of course, is that my protein and RNA data, of course, is in a generative sense this time. So there's no allusion to the context behind the data. So in a generative sense, it's data sonification. So that is the data is being sent out as control voltages to the Make Noise microsound machine, and it is also at the same time being mapped to spatial trajectories to move audio sources around using higher order ambisonics. And of course, the easiest thing to do would be to also map some of those trajectories and some of the data to the Corpus Explorer patch as well. So, modulating different parameters of the granular synthesizer that was, being that was playing the grains essentially, and navigating it as well, navigating the two-dimensional Corpus window or Explorer. So improvising with this system kind of brought about this idea of having a dialogue with the data, because essentially it felt to me that that's what I was doing. Kind of playing together with the data, not knowing when I load in the next sort of batch of 10 proteins into the system, what's going to happen. But each of those sort of data points or those data vectors, essentially, because it's multidimensional, each of those vectors were being mapped to different places. So as I loaded in, I would essentially generate a new soundscape. So I could have diverged from what I was playing at that time. At any moment when I sort of loaded in the next batch, or it could have also been similar, or just augmented slightly. So something would change, but it would still be very much the same sound world or the same soundscape, but some element would change. So this sort of surprising aspect of it, and the fact that I had to respond to that musically and spontaneously in real time was great, was fascinating, and it felt like a dialogue with those data values. Yeah, that's how it happened, I guess, with data dialogues.
Yeah, it's really interesting to hear how hear about this trajectory across these different pieces, and yeah, how this data has sort of gone from a source to up to, in this piece, sort of being in dialogue with it, and hearing about how that kind of relationship has built up over the years. And so, is it across these projects? Is the data set the same, or is it something that's perpetually updating, or?
It is different sets of data. So it is a similar data type, because the patches is built around that data type. So it's vectorial multidimensional data, essentially. But it is different data sets collected from different experiments conducted at various different points in time. So and they all have different sort of dimensions as well. So some of them have more dimensions, some of them have fewer dimensions, or higher or lower throughput as well. Yeah.
And I suppose one question is, would you say that over the course of this sort of aesthetic engagement that you've had with this type of data, do you feel that you may have gained, even if it's not something that you could sort of say or explain or tangibly sort of put your finger on, do you think you may have gained some kind of comprehension about that kind of data? Do you kind of have some kind of how would we say, a sort of intuition about this data? Do you feel that you've sort of got to know it in some way?
In a way, I guess I can. I mean, I cannot really say that objectively and provide evidence to support it, but I can say that, yeah, I've kind of learned its behaviors, if I can say it that way, in terms of sonic output or the way that it's translated into sound. And some of it is audible, of course. When you play more and more with the same data set, especially if you use the same data set, or if you change data sets, then it's far more difficult to kind of gain that understanding, which is, of course, what I did. I both did change, but I also played with using the same data set, for an extended period of time. So I did kind of get an understanding, a vague understanding of behaviors that I could expect during performance. And that's how I kind of practiced or rehearsed for the performance, because every time it was going to be something different. There was no real directed way that I could, make sure that I was on top of every single aspect of live free improvisation that I was doing. Of course not. But I was, I guess, prepared in a sense to respond accordingly based on vague expectations of what the data could bring about all of a sudden.
Yeah, I think it's a really interesting concept, and it's something that I think it could really interest the hard sciences. This kind of aesthetic engagement with data, and even if it's not something that you can quantifiably and objectively kind of discuss or communicate, I think this kind of visceral, it's a really interesting idea. One thing I wanted to ask you about, so you mentioned it briefly, another system that you've worked on that also uses some of the FluCoMa tools is an AI listening system.
Yes.
I wonder if you could perhaps talk about how that works, and perhaps more generally, how you conceive of a computer that listens in your work, and how you may articulate it with your own ear. And I wonder if sorry, the work, because it's complicated work, it escapes my memory, but angiogenesis, malignant angiogenesis, there was a mapping between some of the sound output and the image generation. I wonder if that was using this kind of AI listening system or not.
No. At that point, I was not using machine listening and malignant angiogenesis. So that was linear interpolation essentially, and that was sort of direct mapping or exponential mapping between parameters. But with the AI listening patch or feature of my Corpus Explorer patch, which I came to call Plotterz, but that's the official name, by the way. And unofficially, it's always been called Harry Plotter. And yeah, I mean, that was kind of it's always been a joke, but yeah, I decided not to put the official name down as Harry Plotter, because then people would think that it's not serious. Anyway, so the way that's designed is it primarily uses the multi-layer perceptron regression network, and it's in addition to recording sort of input audio into a buffer and using the slicer objects in the FluCoMa toolkit, sort of and concatenation essentially. In addition to decomposing the audio and plotting it also using these regression networks that are trained on essentially mostly MFCC analysis, so the melt frequency cepstral coefficients that are derived. So those data points are then being fed into the regression network, and reducing their dimension, their higher dimension to essentially navigate so into 2 dimensions, from the higher dimensions down into 2 dimensions to navigate the Corpus Explorer. But also, tapping into the hidden layers of the regression networks, I also extract other sort of parameters or data for other parameters of the synth as well. So it's kind of tapping in there and also getting the output to modulate different parameters. So the way I conceive of the machine listening is this kind of similar way that I approached using data in earlier in data dialogues. In many senses, in many ways, I look at it as another performer, and similarly as another dialogue that I'm having with some cyber data entity, kind of to put it in that way, I guess. Yeah, and I often stumble on really interesting results because I mostly use it as a live improvisation tool. So it interjects me. It sometimes builds on what I'm doing. And of course I exert my control as well. I can limit the extent of its control of the AI listening control of the synth. So I can allow it at some points to explore the one corpus while I'm exploring the other corpuses in my patch, or I can allow it to take over. I can cut that access and freeze its sort of function. So then that would allow me to find these moments. So it could interject me, but that interjection could build into a whole other section that I can then build on. Or if I'm, playing an instrument, for instance, if it lands me on some other area of my 2-dimensional corpus display, then it triggers or inspires me to do something else on my instrument, to make a shift, or to develop something further. For instance, to develop a phrase further, or yeah. So it's this, again, as you see, it's this kind of dialogue that it has a very intriguing effect on the output itself, and also on how I approach and listen to, what it's doing. I find that in many ways it has made me more attentive to, to listen to. I mean, obviously, if you're live improvising, you have to be as attentive as possible. You really have to be all the way in the moment. But I think this even enhances that, because I really need to be prepared. I don't know. I mean, to some extent, I can expect it to do certain things based on how the model is trained, but that's not always consistent. Like it can misbehave sometimes, and those sort of instances can produce really interesting results, or open up sort of new possibilities in the improvisation, and new directions that suddenly the piece can go. Yeah, so it's and I do have to add, this is something that I'm still working on. So I have sort of ideas to kind of network different neural networks with one another, and I've already kind of done that to an extent, but it's still work in progress. So kind of feeding the influence of one regression network into another one, and then sort of cascading, and then see what kind of result I get. So this is something that I'm kind of playing this around with at the moment, and my understanding, of course, is going to change, and the way I feel about it as well as a performance tool most probably is going to change. At the moment, this is where I am with it. So I kind of like it, and I trust it to not entirely ruin my performances, and it hasn't really done that yet. Mainly because I am very much on top of it. If I sense that it's going somewhere that it shouldn't do, I freeze it. I stop letting it take control. Yeah.
Yeah, well, it's good to hear that you're sort of encroaching on that balance that I think many people try to find between chaos and surprise and control. And it's something that's not easy to find, and it can take a lot of fine tuning and requires experience with one's own patches, I think. It's also, but yeah, no, it's interesting to hear how you kind of fashion the computer into this very active agent that's really performing with you and making decisions that are impacting the work.
Slightly anthropomorphic, I would say. I kind of sometimes see it as a person, but it's not the case. But just a side note.
Yeah. Another thing I wanted to ask you. So you've worked with both Super Collider and Max over the years, and you mentioned earlier that your upcoming album is using a lot of Super Collider. I'm always curious to hear people explain sort of what drives them towards one creative coding environment to another, what you consider to be the affordances and limits of each, and sort of generally describing their relationships with the creative coding environment in their practice. So I wonder if you want to talk about that, and maybe also talk about this upcoming project that's on the way.
Yeah, absolutely. Well, in all honesty, I resisted Super Collider for quite a while. Scott Wilson, recently told me that, the great irony that, you resisted it for so long and then you ended up doing a whole album in it. And I was like, yeah, he is right. But the main reason I resisted it was because I just found my creative coding side to flourish in Max, and learning curve in Super Collider, of course, is very steep. And I am, of course, familiar with code, with C-based languages. I studied C# and I know C++. A little bit, not that well. But I'm generally comfortable with code. It doesn't really scare me off. But there was something that blocking me, and I think that was, for me personally, was debugging and troubleshooting per se in Super Collider, which is really tricky, can be really tricky sometimes, and can make you pull your hairs out. but yeah, anyway, during the lockdown, of course, Scott was kindly sort of hosting Super Collider sessions, teaching us, and we also had sort of live jamming sessions, which was wonderful, and I learned a lot, and that sort of started me down, or send me down this sort of this path. And then I, ended up using it a bit more and more. And nowadays it's kind of integrated into my performance set. So I am feeding the audio from my Super Collider patches into my MaxPass, so that the interconnectivity that I mentioned earlier. So I find myself, modulating parameters on VCD rack with, using OSC, and then feeding the audio into, my max patch, and then, feeding a Super Collider into max patch, and, just a crazy matrix of, just parameter mapping everywhere. Nowadays, I find that it really depends on what I want to do, which coding environment I would pick. So the album that you asked about, which will hopefully be out soon, is essentially a combination of what I call a bleep bloopy computer music aesthetic with Persian classical music harmony. So what I did was that I drew on modes and scales, which were derived from Persian classical music, and I used lots and lots of random generators, essentially to operate various synths that I've made in Super Collider, and they're mostly experimental FM synths, and so there's this combination of algorithmic, stochastic musical elements, and also harmony that stems directly from Persian classical music, and that's the sort of whole premise of the album. It is called Random Walks, and because I use a lot of Brownian motion patterns, and that's the kind of core algorithmic drive behind the whole album. But just to add as well, most of the pieces are semi-improvised, if not more than a bit semi. Maybe a bit more. Like there are fully improvised pieces as well. So there are some tracks, of course, that are fixed, that have a lot of sort of post editing and fixed composition. And directed composition, but there are some that are just purely improvised, fully improvised. Some of them employ sort of just live coding, just mouse and keyboard, and others I've used MIDI controllers to kind of modulate synth parameters. So for that kind of aesthetic, anyway, going back to what makes me choose one over the other. For me personally, if I'm going after something pitch-based and using stochastic algorithms, I find that Super Collider gives me more flexibility and control over that, and I kind of like the output of it in that sense. I'm not saying that you can't do these things with Max. Of course you can, but I just find, I don't know, there's something about working in Super Collider for that specific side that intrigues me, and I find myself going to it. And of course, if I want something highly modifiable, then I would obviously go to Super Collider as well, because I have that control to write my own functions, and not have to try to work with a object that's packed. So that amount of control is something that Super Collider I find is good for. But really, I guess it depends, how much patience you have for debugging and troubleshooting, and for prototyping, for instance, I would rarely ever go to Super Collider. If I want to prototype something, Max is the easiest way to go. And then, I might realize that, well, I need, this to happen, or I can, maybe I can use FluCoMa, maybe I can train a regressor network again for this, or maybe I can, make a patch in Super Collider and do this. So, kind of, goal-oriented programming, I would say, that, I kind of conceive, and that's usually my approach towards so the balance between programming and composition side of my work. Did that answer your question?
Yeah, definitely. And the Random Walks project sounds really interesting. So cool. Well, Milad, thank you so much. It's been really fascinating to hear you talk about your work.
My pleasure. Thank you for having me. It's been great to talk with you and to be featured in the FluCoMa podcast series. It's a pleasure.
Well, you're quite welcome. Yeah, I'm sure people have thoroughly enjoyed hearing you talk about your work. So yeah, as always, everything that we've been talking about will be linked on the FluCoMa on the page on the FluCoMa Learn platform where this video shall be living. And if people are watching on YouTube, then they can find a link to that down in the description, as they will also be able to do on the various audio-only streaming outlets that this podcast also appears on. So yeah, Milad, thank you again. Thank you so much. It was great having you.
It's been great. Thank you very much.